After completing this course, the students will be able to describe the specific task to which queues are suited and will be able to apply queues to a specific application.
Queue is a list in which insertion and deletion operation is performed with the two ends. The insertion operation is performed at the rear end and deletion operation is performed at front end. It follows first in first out principle, that is FIFO principle. Here the figure shows the number of elements in the queue with two ends. The insertion process is performed at the rear end and the front performs deletion operations where the elements is deleted through the front end. Here there is operations on queue. Fundamental operations performed on the queue are NQ, DQ, queue overflow and queue underflow. This is the queue model with NQ and DQ. NQ performs insertion operation inside the queue and DQ performs deletion operation from the NQ operation. It is the process of inserting a new element at the rear end of the queue. For every NQ operation, check for full queue. If the queue is full, insertion is not possible. Otherwise, increment the rear end by 1 and then insert the element in the rear end of the queue. DQ operation. It is the process of deleting the element from the front end of the queue. For every DQ operation, check whether the queue is empty or not. If the queue is empty, deletion is not possible. Otherwise, delete the first element inserted into the queue and then increment the front by 1. It follows first in, first out principle. The first element should be deleted from the first element. Queue overflow. It is the process of attempting to insert an element X at the rear end of the queue. When the queue is full, the queue overflow will happen. For every NQ operation, we need to check this condition. Queue underflow. An attempt to delete an element from the front end of the queue. When the queue is empty, it is said to be queue underflow. For every DQ operation, we need to check this condition. Implementation of queue. Queue can be implemented in two ways. Implementation using array and implementation using linked. Array implementation of queue. Now we are declaring the array inside the queue. Int queue of 5. The 5 represents the maximum size of the array inside the queue. Queue empty operation. Initially, the queue will be empty. With empty queue, front and rear points to -1. It is necessary to check for empty queue before deleting an element from the queue. Then routine to check for empty queue. Int is empty queue. If front is equal to -1 and rear is equal to -1, then return the value. Queue full operation. As we keep inserting the new elements at the rear end of the queue becomes full. When the queue is full, rear reaches its maximum array size and there is no insertion will happen. For every NQ operation, we need to check for full queue condition. Routine to check for full queue. In the queue, the array maximum size of the array is given and the elements which is inserted to the queue is full. The routine to check for full queue. Int is full queue. If rear is equal to array size -1, then return the value. NQ operation. It is the process of inserting a new element at the rear end of the queue. It takes two parameters X and Q. X is the element to be inserted at the rear end of the queue. Before inserting a new element in the queue, check for full queue. If the queue is already full, insertion is not possible. Otherwise, increment the rear pointer by 1 and then insert the element X at the rear end of the queue. If the queue is empty, increment both front and rear pointer by 1 and then insert the element X at the rear end of the. Now the figure shows the empty queue, and now we are inserting 10 into from the front end. DQ operation. It is the process of deleting an element from the front end of the queue. It takes one parameter DQ. Always front element in the queue will be deleted. Before deleting an element from the queue, check for the empty queue. If the queue is empty, deletion is not possible. If the queue has only one element, then delete the element and represent the empty queue by updating front is equal to -1 and rear is equal to -1. If the queue has many elements, then delete the element in the front and move the front pointer to next element in the queue by incrementing front pointer by 1. Routine for DQ. Void DQ Q. If front is equal to -1, printf empty queue, deletion not possible. Or else, if front is equal to rear, X equal to Q front is equal to -1, rear is equal to -1. Else, X equal to Q front is equal to front plus 1. Now we will see about linked list implementation of queue. Queue is implemented using singly linked list operation. NQ operation is performed at the end of the linked list and DQ operation is performed at the front of the linked list. With the linked list implementation for empty queue, front is equal to null and rear also should be null. Link the list representation of queue with 4 elements. Here the picture shows having 4 elements in the linked list in the queue operation with the front end and the rear end. Declaration for linked list implementation of queue ADT. Now we are declaring a node and the operations are declared within the node and inside the node how many indexes are there also declared. Struct node, type def struct node q, type def struct node pointer position, int is empty q create q void make empty q void nq int x q void dq struct node int data position next front is equal to null pointer rear is equal to q empty operation. Initially q is empty. With linked list implementation, empty queue is represented as s next equal to null. It is necessary to check for empty queue before deleting the front element in the routine to check whether the queue is empty. Int is empty q. If q next is equal to null, return 1. NQ operation in the linked list implementation of queue. It is the process of inserting a new element at the rear end of the queue. It takes 2 parameters. Already we have seen X and Q. The element X to be inserted into the queue. Using malloc function, it will allocate the memory for the new node to be inserted into the queue. If the queue is empty, the new node to be inserted will become first and last node in the list. Hence, front and rear points to the new node. Otherwise, Insert the new node in the var next and update the var point. Routine to enqueue an element in queue. Void enqueue int x comma qq struct node new node. New node is equal to malloc size of struct node. It represents the new node. If var is equal to null, new node data equal to x and new node next is equal to null. Q next is equal to new node. Friend is equal to new node. Rar is equal to new node because friend and rar representing node. Else new node data equal to x. New node next is equal to null. Rar next is equal to new node. Rar is equal to dequeue operation. It is the process of deleting the friend element from the queue. It takes only one parameter. Always element in the front. Element pointed by queue next is deleted always. Element to be deleted using temp. If the queue is empty, then deletion is not possible. If the queue has only one element, then the element is deleted and front and rear pointer is made null to represent empty queue. Otherwise, front element is deleted and the front pointer is made to point to next node in the list. The free operation informs the compiler that the address that temp is pointing to is unchanged, but the data present in that address is now undefined. Routine to dequeue an element from the queue. Void dequeue queue struct node pointer temp if front is equal to null, error empty queue, deletion not possible. Else if front is equal to rar, temp is equal to front. Queue next is equal front is equal to null, rar is equal to null. Free temp. Else temp is equal to front, queue next is equal to temp next. Front is equal to front next, free temp.
Now we will move on to the question and answer section. The first question is a linear list of elements in which deletion can be done from one end, that is front, and the insertion can take place only at the other end, that is where is known as. The options are queue, stack, tree and linked list. The answer will be option A, queue. The second question is a queue follows option A, FIFO, first in first out principle. Option B, LIFO, last in first out principle. Option C, ordered array. Option D, linear tree. The answer is option A, FIFO, first in first out principle. Thank you, students.